Thanks very much, and thanks again to Nicholas and Sharon and Paul and the Reed corporate team for putting on such a great event over the last couple of days, and the dinner was very enjoyable last night. My name's Rick Pobjoy. I'm the Acting Managing Director and co-founder of Australian Rare Earths. Australian Rare Earths is working towards establishing an independent, sustainable supply of critical rare earths for use in decarbonisation efforts through the development of its Copper clay-hosted heavy rare earth project. It's the usual disclaimer here. This presentation includes forward-looking statements and is not intended as financial product advice. Demand growth for EVs and wind turbines require 4 key rare earth elements. The Western world is seeking independent and diverse supply chains for these materials. However, deposits containing all 4 of these key rare earth elements are rare. Copper has all 4 key rare earth elements, including, importantly, the heavy rare earths, dysprosium and terbium. It is those 2 rare earth elements that allow a rare earth permanent magnet to operate at higher temperatures in electric vehicles and in wind turbines. And without those heavy rare earth inputs to the rare earth permanent magnet, those magnets wouldn't operate in those applications. Copper has a substantial JORC resource already defined of 101 million tonnes at 818 ppm TREO, total rare earth oxide, which is open in all directions, and the project area more broadly has an up to 1.4 billion tonne exploration target. It's a clay-hosted deposit, the same style that's underpinned China's massive rare earths industry. And a useful statistic to illustrate that point is that clay-hosted resources in China only amount to about 1% of their total rare earth resources. However, production from them is as much as 35%. We have immense growth potential at Copper. The defined resources are within less than 5% of our total acreage. And the growth potential has been demonstrated in our 1.4 billion tonne exploration target. We have region-wide drilling showing potential for rare earth mineralisation across our 4,000 square kilometre tenure. Further resource expansion and development drilling is underway and has been since early February this year. We have an MOU in place with Neo Performance Materials, which speaks to a joint development and an offtake agreement. Neo are one of the few companies outside China who are taking rare earth products downstream. They have a wealth of experience in the industry, and that we will be able to tap and rapidly progress Copper. Stakeholder engagement and baseline studies for a mine lease application are underway. We have a strong community engagement in the region that we're operating in. We're an Australian company, and not just by name only. Our board includes, as its chair, Professor Dudley Kingsnorth, who is internationally recognised as a rare earth industry expert. We recently concluded a capital raise, raising $11 million, and with over $17 million in the bank, we're extremely well funded to continue the exploration and development of Copper. So Copper, our cornerstone asset. It's a highly valuable potential source of critical rare earths in a Tier 1 location. We're 100% owned, clay-hosted critical rare earths deposit located just 300 kilometres southeast of Adelaide, with over 4,000 square kilometres of exploration tenure. A recent mineral resource upgrade has confirmed Copper as a globally significant resource, 101 million tonnes at 1,818 ppm. And with a greater than 1 billion tonne exploration target, we believe we have uncovered a rare earth mineral province right there in South Australia. The mineralisation across the region is consistent and shallow, which facilitates rapid, low-cost exploration and potentially mining. Metallurgical testing has confirmed the presence of recoverable, light and highly sought-after heavy rare earths. Recently announced test work has also shown a pathway to beneficiating this ore, allowing for lower processing costs. We've been actively engaging with the local community, knowing that their support is key to a successful business. currently preparing the inputs for a mine lease application and have established an MOU with Neo Performance Materials. This will allow us to rapidly progress this project. Our aim is to become a global supplier of added value rare earth products, working alongside government, academia, community and landowners. So our current mineral resource, 101 million tonnes, contains consistent magnet rare earth content. And again, those magnet rare earths, neodymium, praseodymium, terbium and dysprosium. Consistent magnet rare earth contents of around 25% of the total rare earth content. More than 60% of the 100 million tonnes is in the indicated JORC classification, and that indicated portion has a higher average grade than the inferred resource. The resource has huge potential for growth with a 1.4 billion tonne exploration target attached to it. The resource definition drilling is underway and has been since February. The areas shown as blue dots on the map here now have assays flowing in. This very large area here of new drilling and other areas attached to the existing resource in blue now have assays flowing in, which will allow for a further resource update scheduled for the next quarter. A wider view here of the regional drilling we've undertaken and the exploration target areas outlined in, outlined in blue here, attached to the resource. Where we have observed the same sorts of thicknesses and grades of clay-hosted rare earth mineralisation up to 40 kilometres away from the defined resource and essentially everywhere in between. The entire region appears endowed with rare earth mineralisation hosted in clays, and we have in our 4,000 square kilometres of tenure almost all of the prospective ground covered for this style of mineralisation. We've also commenced resource definition drilling in the area of the northernmost exploration target, where we've gained land access, and have approvals granted to conduct road verge drilling to expand the exploration target in the areas shown outlined in red there, another very large area of potential mineralisation. So what are our next steps? I've spoken about the important work we're undertaking in understanding and expanding on the rare earth resources at Coppermurra. We'll also be continuing our early and active engagement with local communities. We understand their support is key to building a successful business. Further exploration and resource drilling is well advanced. The non-binding MOU we have with Neo Performance Materials is being progressed towards a binding agreement. Metallurgical test work continues, focused on optimising the production process flow sheet. We continue to prepare the inputs for a mine lease application. Coppermurra can become the multi-generational location for the production of added value rare earth products, working alongside landowners, communities, government, academia and research organisations. A little on the metallurgy. Importantly, in developing this project, we have demonstrated the recovery characteristics essential for a clay-hosted deposit through a mild acidic leach at ambient temperatures and pressures. In a real milestone for the project, we recently produced a mixed rare earth carbonate from an 800 kilogram bulk sample taken from Coppermurra. That is already meeting many of the specifications required for downstream users of those products. We've also been working on refining the recovery process to minimise the use of reagents. And in another milestone achievement, announced just yesterday, test work results showing the ability to beneficiate the ore, thereby potentially reducing capital and operating costs. We've established a world-class metallurgical team and are well and truly leading the pack with respect to a development of this kind in Australia. So why are clay-hosted deposits so important? I've already highlighted the importance of the heavy rare earths that they contain. Clay-hosted deposits have a range of other important benefits when it comes to developing the supply of critical rare earths. They require only simple metallurgical recovery processes operating at ambient temperatures and pressures to produce from, and in doing so, they produce no radioactive waste streams. This means that the upfront capital expenditure required to bring them into production is dramatically less than that required for hard rock or monazite sands sourced rare earths, and that they are entirely scalable. The resource at Copper is shallow, free digging, and with a low strip ratio, has a proposed mining method that will allow for rapid progressive rehabilitation of the ground. How shallow? The over 4,000 drill holes completed to date average only 10 metres in depth. And this image here of a trial pit we established also illustrates just how shallow the clay material over the limestone in the region is. The bulk sample we used for metallurgical test work and the production of a mixed rare earth carbonate came from the trial pit we conducted. A total of 500 tonnes of mineralised clay was collected from that site and is available for scaling up further process work in a pilot plant. The test pit also allowed us to establish the type of equipment that we would be required for mining a deposit of this type, and importantly, how well the pit could be rehabilitated and the land returned to its former use, in this case, grazing sheep. And I'll just highlight that lower image is actually the after shot. So it's after we rehabilitated that site and returned the topsoil, the pasture returned, and it was available for the landowner to put his sheep on it. So bear with me. So by becoming part of the community and engaging with them as often as possible about our activities and plans, we're establishing broad acceptance of our project in the region. We have an office and warehouse established in the town of Naracoorte, and we often get involved in community events so as to bring visibility to our project. So why Australian rare earths? Well, the Copper project has a large resource with exceptional potential for multi-generational growth. A substantial market opportunity exists driven by global decarbonisation efforts. We have an endowment of all four of the high-value rare earths. Critical rare earths, neodymium, praseodymium, terbium and dysprosium are essential ingredients in permanent magnets for EVs, wind turbines, robots and domestic appliances. We have a Tier 1 location with strong community, landowner and government support. We've demonstrated the production of a mixed rare earth carbonate at scale, and that's meeting many of the specifications required for downstream users. Project support through our partner Neo Performance Materials is an important element of our project. There is strong demand growth supported for the need for a sustainable, independent supply chain of these materials. That's Australian rare earths and Copper. Thank you.